today we are from Group 1 and today we will present about Unix file management, which include also Linux virtual file system and Windows file system. So the definition is file management is a critical aspect of operating system, controlling how data is organized, stored, and retrieved on a computer. Unix-based systems like Linux and Mac OS and Windows system differ significantly in how they handle the file system hierarchy. So first, we will talk about the Unix file system. So the first and foremost Unix file system um, is a logical method of organizing and storing large amounts of information in a way that makes it easy to manage. Um, a file is the smallest unit in which the information is stored. And then the data in Unix is organized into files, and then the files are organized into like some sort of directories, and then these directories are then organized into tree-like structure. And then on the top of a file there is root or like that is represented by backslash, and then all the other files are descendants. It also uses a set permission to control access to files and directories. Each file and directory has an owner and a group associated with it, and permission can be set to allow and restrict access to these entities. Uses symbolic links which are pointers to other files or directories. Okay, so this is the um, Unix directory tree, and as you can see there is root on the top of the tree which is represented by the backslash, and then from the root we can see that the files and the directories are derivative of the um, directory of the root. So for each we can see that first we can see the bin, which is stand for the binaries, which is contained fundamental by utilities. And then we have slash boot, which is contains all the file required for booting, and then slash dev, which is for devices, and then slash etc. This contains system-wide configuration files and the system database. And originally also contained dangerous maintenance utilities such as init, but this has been moved to sbin. And then we have slash home. Slash home is contains home directories, and then slash lib, which contains system libraries and some critical files such as kernel modules or device drivers. And then we have slash media, which is default mount point for removable drivers such as USB sticks, media player, etc. And then slash mnt, which stands for mount, file system mount points. And then we have slash proc. This also contain procs fs virtual file system showing information about processes as files. And then we have slash root. Slash root is a home directory for the super user root, that is the system admin. And then we have slash tmp. Slash tmp is a place for temporary files. Many systems clear this directory upon startup. It might have tmpfs mounted on top of it, in which case its content do not survive reboot, or it might be explicitly cleared by startup script at the boot time. Then slash usr, which is holding the user home directories, um, which is now it actually holds the back then actually holds the direct holding user home directories. Now it actually holds executable libraries and shared resource that are not system critical. And then we have slash usr slash include stores development headers used throughout the system. Header file mostly used by the include directive in C and C++ programming language. And then you have slash usr slash lib source required libraries and data file for programming stored within user usr. And then slash var, a short for slash variable, a place for files that they contain often, especially in size. For example, email. And then we have slash var slash log contains system log files, slash var mail, slash var slash mail, which contains all incoming emails. They can, and then slash var slash pool, which is pool directory. They contain print jobs, mail spools, and other queue tasks. Slash var slash tmp, a place for temporary files which should be preserved between system reboots. So then we get into the classification of Unix file system. First, we have ordinary file, which is actually the actual data file itself. It contains data, text, or program instruction that is used to store information. It is always reported under a directory file, and it does not contain other file, and it is represented by the dash symbol. Directories. These directories store special and ordinary files equivalent in what we know as folders. Um, it contains an entry for every file and subtree that it houses. And then it branch it in the tree they are the branching points, and then it is only used for organize the files, but it does not actually have the data that we search for. It might contain the file specially or a special or other directory, and is specified by the this symbol. And then we have special files. Special files represent IO devices. There are two types of it, which is character special file, which are the data that are transferred at a time and called raw device access. They are marked by C. And then block special file, data transferred in large fixed size blocks and called block device access. They are marked by the symbol B. And then we have pipes used to link commands, one-way flow of data, and then put a vertical bar on the command line between two commands line. Output of first command is used as input of for the second. They are marked by the P symbol. And we have socket, which is a special file which allows advanced inter-process communication. They are used in the client-server application network. It is actually just a stream of data, very similar to network stream, but all transactions are local to the file system. They are marked by the S symbol. And then we have symbolic link. The symbolic link are used to reference other files. It also contains a text form of path to the file it references. They have its own name, but when written to it, it will be stored into the file at it reference. It is marked by L. And then we have advantages, and then we get into the advantages of Unix file system. Unix file system, it has hierarchical organization that makes it easy to organize and navigate files. And then also its robustness. It is known for its stability and reliability, where it can handle large amount of data without becoming unstable or crashing. Then we have security. They use a set of system permission that allows administrators to control who have the access files and directories. And we have compatibility. It is widely used and supported, which means that the files can be easily transferred between different Unix-based systems. And disadvantage of Unix file system. It is very complex. It is very complex to understand and manage, especially for users who are not familiar to the command CLI, which is command line interface. The steep learning curve is hard to learn for those who are not familiar. And then it lack of user-friendly interface because it uses command line interface instead of graphical interface. And lastly, there are limited support for certain file systems. They are not compatible with some file system. Then we'll move on to the next part of the lesson.
Assalamualaikum warahmatullahi wabarakatuh. I am Abdul Ghafur bin Fadi. I will be explaining about the Linux Virtual File System VFS. VFS is a software layer in the kernel that provides the file system interface to user space. The VFS is sandwiched between two layers, the upper and the lower. The upper layer is the system call layer where a user space process traps into the kernel to request a service, which is usually accomplished via libc wrapper functions, thus catalyzing the VFS processes. Next is the lower layer. It's a set of function pointers, one set per file system implementation, which the VFS calls when it needs an action performed that requires information specific to a particular file system. The VFS could be thought of as the glue between the user space application's requests for file-related service and the file system-specific functions which the VFS invokes as needed. Okay, as you can see, this is a standard abstract interface of what I just said before from a high-level view, as you can see. Okay, why virtual file system? It acts as the interface between the user and the files backing file system, masking any implementation details behind generic calls such as open, read, write, etc. Thus, VFS provides an abstraction within the kernel which allows different file system implementations. It also provides a standard interface used to allow a kernel to use various file systems. VFS is also responsible for file system locking, registering, and mounting a file system, and file structure placement into the file descriptor table for the process. The primary benefit of VFS is that most user space programs are naturally written in a completely file system independent way. Okay, this is object of virtual file system. This includes 4 objects. Okay, of course there is more, but we will be explaining about this only first. So the first one being superblock. This structure actually holds data needed for performing actions and the file system, such as mounting. Next is dentrace or dentries. This represents path names and are used to search through the directory entry cache or dcache for a specific dentry. Next is inodes. These represent objects within the file system and are used to keep track of files. And lastly, files. These hold information for each open file, such as cursor positions. Okay, we may proceed to explaining each of these objects. First one is superblock. This describes how the VFS can manipulate the superblock of your file system. Okay, as you can see, struct super underscore operations. The following members are defined. As you can see, this is the list of things you can do in super block actually. For a super block, all methods are called without any locks being held unless otherwise noted. This means that most methods can block safely. All methods are only called from a process context, which is not from an interrupt handler or button house. Okay, this is the one of the example of things you can do in superblock structure. Okay, the first one being alloc inode. Okay, it is used to allocate memory for struct inode and initialize it. Next one being net destroy inode. Okay, it is used to release resource allocated for struct inode. Okay, for struct inode. Next, free inode. Okay, this method is called from RCU callback. It is better to release memory in this method actually. Okay, next example we have write inode. This method is called when the VFS needs to write an inode to disk. Last one, drop inode. It is called when the last access to the inode is dropped. When the inode is ilock spin lock held. Okay. For the next object, we have dentries. So the VFS implements the open stat mode and similar system calls. The path name argument that is passed to them is used by the VFS to search through the directory entry cache. Okay, this provides a very fast lookup mechanism to translate path name into specific entry. The entries live in RAM and are never saved to disk. Remember that. Okay, they exist only for performance. The entry cache is meant to be a view into your entire file space, as most computers cannot fit all the entries in the RAM at the same time. Some bits of the cache are missing. In order to resolve your path name into a entry, the VFS may have to resort to creating entries along the way and then loading the inode. This is done by looking up the inode. Now, this describes how a file system can overload the standard entry operation. The entries and the dcache are the domain of the VFS and the individual file system implementations. Device drivers have no business here. This method may be set to null as they are either optional or the VFS used as default. Okay, as you can see, just like superblock, but this time it is use struct entry operation. The following members are defined. As you can see what it can do under D3 operation. This is the example we can take from structure and trace what it can do. The first one being de-revalidate. It is called when the VFS need to revalidate a entry. Okay? This is called whenever a name lookup finds an entry in the D cache. Most local file systems leave this as null because all the entries in the cache are valid. Network file system, however, is different, since it can be changed without the client actually notice it. The function should return a positive value if the entry is still valid and 0 or negative error code if it isn't. The next one is dweak revalidate, called when the VFS needs to revalidate a jumped entry. This is called when a path walk ends at the entry that was not acquired by doing a lookup in the parent directory. This includes slash, dot, and double dot, as well as procfs star symlinks and mount point traversal. Then we have dhash, called when the VFS adds a entry to the hash table. And the last example is dcompare, called to compare a entry name with a given name. The first entry is the parent of the entry to be compared. The second is the child entry. We will be proceeding to the third objects, that is inodes. So inodes are file system objects such as regular files, directories, FIFOs, and RDBs. They live either on the disk for block device file systems or in the memory for pseudo file systems. Inodes that live on the disk are copied into the memory when required and changed to the inode that are written back to disk. A single inode can be pointed to by multiple entries. Okay? An inode object represents an object within the file system. For inodes, it is struct inode underscore operation. This describes how the VFS can manipulate an inode in your file system. The following members are defined. As you can see, we have create, lookup, link, unlink, symlink, and many more. Again, all methods are called without any locks being held, unless otherwise noted, just like superblocks. One of the things it can do is create, called by the open and create system calls, only required if you want to support regular files. Next is lookup, called when the VFS needs to look up an inode in a parent directory. The name to look for is found in the entry. Okay. Then we have link, only required if you want to support hard link. You will probably need to call the instantiate just as you would in the create method. Next is unlink, only required if you want to support deleting inodes. And the last one being symlink, only required if you want to support symlinks. And finally, files object. Opening a file requires another operation, which is allocation of a file structure. This is the kernel-side implementation of file descriptors. The freshly allocated file structure is initialized with a pointer to the entry and a set of file operation member functions. Okay. The file structure is based into the file descriptor table for the process. Reading, writing, and closing files and other sorted VFS operations is done by using the user space file descriptor to grab the appropriate file structure and then calling the required file structure and method to do whatever is required. For as long as the file is open, it keeps the entry in use, which in turn means that the VFS inode is still in use. A file object represents a file opened by a process. This is also known as an open file description in POSIX parlance. Okay, here is the structure of files, which is struct file underscore operations. This describes how the VFS can manipulate an open file. The following members are defined. As you can see, it has llseek, read, write, read underscore iter, write underscore iter, and many more. Just like before, all methods are called without any logs being held unless otherwise noted. So as you can see, there's this is what files can do. The first one being llseek, called when the VFS needs to move the file position index. Next is read, called by read and related system calls. Next is read iter, possibly a synchronous read with IOV iter as destination. Next is write, called by write and related system calls. And lastly, write iter, possibly a synchronous write with IOV iter as source. As you can see, there's a lot more object in VSF, but we will only cover this. Thank you for hearing me to the end.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dini Aulia bin Shamsuddin. Metric number 2112073. Today I would like to present about Windows file system. As you can see, this is a diagram about Windows file system. There are file system which have directories and file systems. What is file system? In computing, file system controls how data is stored and retrieved. It is the method and data structure that an operating system uses to keep track of files on a disk or partition. Other than that, it separates the data we put in computer into pieces and give each piece a name. The data is easily isolated and identified. And information saved in a storage media would be a large body of data with no way to tell where the information begins and ends if there is no file system. There are five types of Windows file system. First one is FAT12, FAT16, FAT32, NTFS, and exFAT. We go we will go through to three types of Windows file system only. First one is FAT32 in Windows. In order to overcome the limited volume size of FAT16, its supported maximum volume size is 2 GB. Microsoft designed a new version of the file system, FAT32, which then becomes the most frequently used version of the FAT, which means File Allocation Table. Next one is NTFS. NTFS is the newer drive format. Its full name is New Technology File System. Starting with Windows NT 3.1, it is the default file system of the Windows NT family. Other than that is exFAT. exFAT, which means Extended File Allocation Table, was designed by Microsoft back in 2006, and it was a part of the company's Windows CE 6.0 operating system. This file also was created to be used on flash drives like USB, memory sticks, and SD cards, which gives a hint for its precursors. Next, we move to the comparison among the three types of Windows file system. The first one, we have compatibility, we have security, supported file size, and supported volume size. We will go through all of it. The first one is compatibility. The three types can work in all versions of Windows. For FAT32, it also works in game consoles and anything with a USB port. For exFAT, it requires additional software on Linux. For NTFS, it is read only by default with Mac and may be read only by default with some Linux distributions. Next one is security. The files belonging to FAT32 and NTFS can be encrypted, but the files belong to the latter can be compressed. The encryption and compression in Windows are very useful. If other users do not use your username to log in Windows system, they will fail to open the encrypted and compressed. Next one, we move to supported volume size. For FAT32, the partition size is no longer than 2 terabytes, which means you cannot format a hard drive larger than 2 terabytes as a single FAT32 partition. Other than that, NTFS allows you to use 64 kilobyte clusters to achieve a 256 terabyte volume. Next one, we move to supported file size. For FAT32, it will fail to support the single files whose size is over 4 gig, while NTFS file system can support the size of single file more than 4 gig, and other than that, for exFAT, the maximum size of single file in theory is 16 gig. In conclusion, compared with NTFS and exFAT, FAT32 comes in higher compatibility in old operating systems and removable storage device, whereas its features limit in single file size and partition size. And that is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq. Entry number 2211305 will present about the features and advantages of Linux Visual File System and Windows File System with their challenges and limitations, and also the differences between both of them. So let's move on. For the first part is the features and advantages of Linux Visual File System. Linux Visual File System has powerful command line interface. The command line interface in Linux is an asset to power users and developers. It also has open source and collaborative. Linux, being an open source project, contributes to the development of many tools and utilities. It is constantly evolving through collaborative efforts from developers worldwide. Linux also has strict file permission. Intelligent file permissions ensure the security and privacy of system files and applications. Next is features and advantages of Windows File System. Windows File System has powerful search options. Windows provides a powerful and flexible search interface that allows users to find files more easily. It also has Active Directory integration. The Active Directory integration is a critical feature of the Windows File System, making it ideal for business environments. Windows also employs an easy-to-use graphical user interface that makes it user-friendly file management system. And lastly, robust integration with Microsoft products. The Windows File System integrates with popular Microsoft products for enhanced productivity, including Microsoft Office Suite and OneDrive file sharing services. Moving on to the challenges and limitations of Linux Visual File System. First challenges is Linux Visual File System has complex learning curve. Linux requires knowledge of command line tools, which can be daunting for users accustomed to a GUI interface, especially for novice users. Secondly is the file mismanagement. Linux allows unrestricted access to system files, leaving it vulnerable to raw sources and errors. And lastly, for the device support, Linux is limited support for some hardware drivers, not updated regularly. Now for the challenges and limitations of Windows File System. Firstly, it has vulnerability to viruses and malware. Windows File System with its GUI-based interface and open sharing model remains vulnerable to malware and virus attacks, which can cause significant data loss. It also has expensive license costs. Windows File System has a high licensing cost, especially for enterprises, making it expensive to operate on large scales. And it also has issues with privacy. It is because Windows monitors user activities and collects data about the user system and activities, which can be a privacy issues.
For the differences between Linux and Windows file system, firstly, for the file hierarchy, the Linux file system hierarchy is organized differently, while Windows continues with the traditional file path organizations. For the tools, Linux dominated with command line tools, while Windows has a powerful file explorer and PowerShell command line. For the ownership and permission, Linux file system strictly enforce ownership and permissions, while Windows employs a flexible permission model.